Welcome back to the Rust book Speedrun. Here we are, we're checking out the slice type, which is 4.3 in the Rust book. So let's see what we have to learn about the slice type. It lets you reference a contiguous sequence of elements in a collection rather than the whole collection. It's a kind of reference, does not have ownership. Okay, interesting that this is an entirely separate concept. It's just a subset of an existing set. Instead of a single variable, it's a sequence, okay, or a sequence of elements. Write a function to take a string of words, return the first word. So in Python, you just do dot split on the space. Okay, so we get an immutable reference to a string, and we're not sure what it returns yet. Probably a slice. First word function has a string parameter. We don't want ownership. We could return the index of the end of the word. Okay, let's start with that. Created our package, convert it to bytes for each index I and reference item in bytes.iterate enumerate. Oh, we have an enumerate. That's cool. If item is the space character or the space byte, I feel like I'm writing Python, return I. Otherwise, return the length of the string. Okay. Does it compile? Yes. Does it work? I have to provide a formatter. Okay, let's create a string. And then we pass a reference to that string, and we get 6. 0, 1, 2, 3, 4, 5, 6. Looks good. So that works. And now it goes through and explains the code. We convert our string to an array of bytes. We iterate over the array of bytes. Chapter 13 for iterators. Each element, enumerate wraps it and returns it as part of a tuple, just like Python. The first element returned from enumerate is the index. The second is the reference to the element. Okay, this all makes sense. There's a problem. The number is only meaningful in the context of the string. It's separate. There's no guarantee it'll be valid. Yep. So if you clear the string, then that number is meaningless. Okay, so the compiler doesn't catch anything. So it's a logical error basically buried in the fact that word is no longer meaningful. It would be a bug. Okay, so we have to track a start and an end index. That's even worse. 3 unrelated variables floating around, but you can solve it with string slices. Ampersand s, and then you use dot dot notation. I think I have to add 1 to this, but I'm going to try it since there's a comma. Oops, S1. It worked. Starting index is the first position in the slice. Ending index is one more than the last position. Internally, it stores the starting position and the length, which is end minus start. Okay, so this slice that it's called does not have all the information that S does. So I guess when S goes out of scope, then we also lose all the slices of S, which is pretty efficient. Okay, so just like Python, you can do dot dot to if you want to start at 0. And you can just do dot dot to get to the end. You don't have to calculate the length. Super helpful. That's a lot like Python with the colon. Okay. Oh, you can take a slice of the entire string. That's funny. And it must be at a valid UTF-8 character boundary. So it sounds like there's some special handling for UTF-8, but we're just talking about ASCII here. Ampersand str is a string slice. Weird. Okay. So instead of returning an index, we'll return ampersand string, which is a string slice. This is the same. This is the same. If it's a space, return ampersand s from 0 to I. Or we can just do dot dot I. Otherwise, return a slice of s that is the entire length of s. Okay, and it did it. Hello colon, or hello comma. Same for the second word function. Same API, that's nice. Straightforward API, hard to mess up because it'll keep the references into the string valid. So you actually get a compiler error if you clear the string on your slices. I got a different error, that's interesting. Oh, what if I make it mutable? Okay, so the slices are immutable borrows, and then we try to modify and it fails. Interesting. Oh, it's explaining exactly that. Nice. Nice. Whoa. Okay, so our string literals are string slices. Wow. Oh, that's crazy. Okay. Slice-a-roo. And if I notate it as ampersand str, string slice, cool. So I can actually, I wonder if I can index while I'm in the brackets there? No, you're not allowed to do that. Can I slice a slice? No. Well, maybe I can, but it doesn't have a known compile time size. All right, I'll quit messing around. This is cool though. So it would be better to write this to take in a string slice and output a string slice. But how do we do that? Deref coercions. Oh, whoa, whoa. You can write it exactly the same? No way. Oh my goodness, whoa, how did that work? Okay, let's read this carefully. You can take slices of literals, that's all a literal is, and string values. Oh, if you can take slices of literals, then you can take slices of slices because literals are just slices. Okay, if we have a string object, we can pass a slice of the string or a reference to the string. Deref coercions, chapter 15. Sounds complicated. All right, I'll just accept it for now. Okay, I'll accept that, sure. All right, other slices. You can do it for an array, and it has type ampersand array of I32. Okay, I'm gonna try that. Let A, is that the type of the array too? Does that even compile? No. So this is an array of I32, actually. Oh, you're supposed to do it like 3, comma, type and size? I don't know. So this should be just the number 1. I can't print that. That's okay. I don't care. As long as this compiles, yeah. All right, I'm gonna accept this. Might be a little over my head, but I got introduced to a lot of new syntax that I now feel familiar with. I would have had no clue what that meant, first of all, or the difference between ampersand string, a string slice, a string literal, and a string object. So great lesson for this one. That's it for this episode of the Rust Book Speedrun. Hope you enjoyed. See you for the next one.